Hey everyone, welcome back to day two of DeSci Kolkata. So I'm really happy that we have Stanley Bishop with us right here from Stanford, and he's been so excited, and I'm really very happy that he's going to give us his insights on the educational side of things and how human-led AI is a very significant aspect to think of. But it's going to be a very informal kind of a conversation. So that's why this format is an ideathon. So I really can't wait any longer to for Stanley's insights. Yeah, welcome, Stanley.
Hello, gosh, you guys. I am so happy to be here. I'm also so grateful to all of y'all for doing this. I feel like what we're going to be talking about and what you guys are covering at this conference is literally one of the most important topics in the whole world right now. And yeah, I couldn't be happier to be here. Avi, what should I do? Should I just jump in? Is there anything you want to do before I go for it?
No, you can just go for it. Yeah.
Oh, okay. Well, hey guys, I am Stanley Bishop, aka Science Stanley, and I am a mathematician by training. I originally worked in quantum field theory and quantum informatics, particularly high performance computing for quantum field theory. I love physics, I love science, and I also love big computers, man. So it was the perfect field for me at one point. And I was actually, I think I was around 23, 24. I'd gotten into my dream graduate program. And about 3/4 of the way through my first year, I started to have these terrible pains in my hands and feet. And then my hands sort of stopped working, which sucks. Especially being someone who writes at the blackboard all day. I couldn't hold chalk when I was trying to write equations. My hand would shake, and so I experienced what unfortunately many people experience. I encountered a rare illness, and I was thrown headfirst into the diagnostic process. Being a patient, I think, is maybe one of the hardest things. And so I had to learn how to navigate the medical system very quickly. This was at a time in the United States before Obamacare was passed. And so if you were a sick person, it was almost impossible to get health care. And at the time, it was something that it felt like the biggest tragedy, the worst thing that could happen. But it was the thing that made me get into machine learning, get into technology, in order to kind of afford healthcare and to take care of myself. I went over to Google, where I led a lot of the early work in multi-internode GPU training for deep learning. So this would have been maybe 12 years ago. And, just the kind of stuff that's in the news, the kind of multi-GPU systems and clusters that, we use now to train large language models. I, in retrospect, almost look at my illness as a piece of luck, because it sort of put me right there to be working with this, technology that's now obviously just creating enormous impact and is pretty fascinating. And then I sort of went on from there. I became a relatively accomplished machine learning architect. I've designed a number of systems in a number of different areas. But I always kind of went back to that experience that I had as a patient. And, I've always thought about that and thought about how I could help. So sort of slowly and through open science and decentralized science, moved my career towards biotech. Thankfully, DNA is a language, proteins are a language. So, many, I would almost say most of the techniques that we use in my original field of natural language processing apply to biotech. But anyway, I was able to make this really interesting transition from a mathematician and a natural language scientist to a bioinformatician and a sort of medical technologist. And um, that was great for me. And I love my work now. But the thing that like was so special was that it all happened through open science and decentralized science, you know? Um, I would say actually even specifically, there's a very special project, which was my first open source project. It's called DeepChem. And I
Hmm.
would quite frankly encourage everyone to go over to deepchem.io and check it out. Um, and oh my gosh, DeepChem is such a special project. It is a community of people who want to make deep learning techniques for medicine discovery widely available. Um, it's an international community. We have contributors in, I think over 50 different countries, and that's just that's the factoid from years ago. So it's probably more at this point. And not just that, but DeepChem has really accomplished something. Medicine discovery technology, very complex, from a computer science perspective, from a physics perspective, very complex. Certainly one of the harder areas of computer science. And it used to be the domain of the big pharma companies. And they kind of guarded their tools jealously. And so when DeepChem started out, it was almost kind of thought of as cute. Oh, they're trying to do drug discovery, open source. How cute is that? But hopefully many of the people listening and in the audience have contributed to open source. And when open source is healthy, when an open source project is well managed and the contributors are passionate, I'll bet on an open source project over a closed project every time. And that's what happened with DeepChem. DeepChem sort of grew to be the most trusted set of tools. Probably got to take at least a moment to shout out one of my favorite people in the universe, the founder of DeepChem, Dr. Bharath Ramsundar. Brilliant man, kind man, incredible teacher, incredible leader. And yeah, what he has done with DeepChem is just so terribly inspiring. And it helped me to make this big, important transition in my life. But I've seen many other people, who have lives, obligations, full-time roles, start to contribute a little bit to an open source project. And then that little bit grows into a little more, and they meet people, they get connected to other people working in the space. And it's something that can transform your life. It's something that can bring you to a new area. It's something that can bring you to a new country. And I think this is the heart of why, this weird machine learning guy from LA has anything to say about Indian education, because through DeepChem and similar projects, I have had the absolute privilege to work with, some of the most brilliant people in the whole world who do happen to be in India. And yeah, through the magic of technology and decentralization, I've had a chance to work with some of the I've had the privilege of working with some of my most brilliant colleagues over there, and I've seen for them too the chance to get connected to projects internationally, to find collaborators in other countries, um, and yeah, many of them to kind of eventually come over here and work with some of the companies here in California. Um, and so yeah, I am just so excited that DeSci India exists, and I'm so hopeful that it will really become a hub for connecting the just brilliant minds over there in India with other minds all over the world, and that we can all do some incredible science together. Um, and that would be kind of my initial spiel and the context for my talk. Um, Avi, would you like me to go talk about anything else specifically or any other direction, or would it maybe be a good moment to
No,
take some
actually,
questions?
what comes to my mind is about when you mentioned DeepChem, it reminds me of my book, actually, the last chapter of my book where I wrote about DeepChem, and I had shared with you earlier. So we have actually on at Nunet we have also tried running it on our platform. So we are there at a good point where we can simulate like run the DeepChem models on a decentralized architecture. So I'm really looking forward to collaborate with you on that. So it will be a really nice
Oh,
thing
well,
to.
I cannot wait, and I have so many fun scientific problems to investigate using deep chem tools. It's been a list that's just growing longer and longer every month. So we'll have to do a call soon, and then maybe talk some more. Um, but Avi, I'm violating. I'm going to violate the format, but then this is an idea-thon, so maybe that's okay.
Yeah,
Um,
yeah,
Avi, is there any chance you'd tell me your story of deep chem, like maybe how you came across deep chem and how it came to be a part of your book?
yeah. Basically, when I was in my fourth year of my PhD, so then I got an offer from Pact Publishing to write a book on GPU computing. So, so they said that the final chapter should be something about the application of AI or machine learning. So, so then I started looking for something that really makes an impact through open source. So then I found deepchem.ai, .io. I'm sorry.
Wow.
So
So
deepchem. Yeah. So
that
then
that IO, that's right. Yeah.
yeah, yeah. So then went through their documentation, and I was able to, I ran some experiments, and I was able to successfully do I was able to successfully run a model on an NVIDIA GPU that I had at that time. So yeah, so that was the experience with DeepCam at that time. So coming
Oh
to
man, that
the yeah, please, you're saying something.
no. I want you to continue, and I have to say I'm so happy that this might turn into us talking a little bit because I've been looking forward to us talking a little more anyway. So we'll this will be an intro to our next Zoom call. But what did you make of it? Like, had you been familiar with the subject of quantum chemistry or computational medicine discovery before you found deep chem?
I have run some molecular dynamic simulations for Staphylococcus aureus, and my most of my work has been about cellular modeling. So actually, it's around the growth of the cell. So finding the mysteries of the cell, investigating into those things. Yeah. So coming to
Incredibly cool. And
topic, yeah. So I wanted to
um,
just go to the topic. That's just have some very brief discussion about it. So uh, we face a lot of centralized hurdles in institutions, and that is why DeSci was born. And uh, can we explore a bit about how AI can help in this scenario, and like what is the role of human-led AI? So maybe we can have a short discussion on that.
oh, that sounds great. And
Yeah.
I think I would start and by talking a little bit about some of the work I've done in medicine discovery. Um,
Yeah.
Traditionally, the computer tools of medicine discovery, as I mentioned, have been inaccessible. There's a number of reasons for that. A big reason is that it used to be very CPU and RAM driven, doing any of these computations.
Yeah.
One of the main subjects that kind of Deep Chem provides tools for, and one of the kind of main tools in the medicine discovery toolbox is something called protein ligand docking. And so,
Yes. Yes. Yeah.
proteins. Oh
Very
yeah,
interesting.
just for the audience, I know you know, sir. Protein is one of these little organic nanomachines that runs
Yeah.
our bodies and all of biology, and then a ligand, that's a molecular ligand. So it's some kind of molecule, some kind of chemical. So in protein ligand docking simulations, you're in 3D visualizing a protein's structure and then also the structure of the molecule, and you're quite literally seeing how they fit together. It's sort of like a lock and key puzzle kind of thing. And yeah, so traditionally, the computer systems that would have been used for protein ligand computations would have been, they call them Beowulf clusters, and it's hundreds, thousands of high CPU power, high RAM capacity machines that are running these simulations. And it's because the structures are so complicated, and for each atom in the molecule, you have to compute the distances to each part of the protein. Um, Deep learning changes this so powerfully. Computations that used to take one of these like extremely inaccessible clusters can now be run on a GPU or a couple GPUs in many instances. So just right there, it powerfully democratizing the application of AI to drug discovery. Um, but yeah, even beyond that, and even when you're talking about GPUs, I feel that pharma companies have some real institutional misalignments of incentive. I can't tell you guys how many times I worked hard to build a cluster or worked hard to build some software for discovery, um, uh, being told by the executives that this is going to be used for cancer, for rare cancers, for rare genetic illnesses. This cluster is different than all the other ones. This one's actually going to be altruistic. And then you end up seeing all the cluster time going to stuff like cures for male pattern baldness, or other things that are certainly wonderful and very important. And again, shout out to HairDAO. I mean, no offense. I think you guys deserve cluster
Yeah,
time
yeah,
too, but I think it's
yeah.
no, and they're the best. So I didn't mean to put down their mission. It's also important, but again, it is sad to see the kind of profit motives of a massively centralized company kind of prevent what feels to me like really important research from happening. And I am not a bleeding heart. I mean, I care so much about the rare disease patients I work with, but I understand too that we need to move science forward as a whole. Businesses need to be functional and revenue generating, but at the same time, there's utility in studying rare genetic disease. Um, One of the main diseases I work with currently is called Ehlers-Danlos syndrome. It's believed to be mainly caused by a single deletion in the tennyson XB gene, but it has extremely different symptomatic presentation from patient to patient. It's very challenging to suss out how exactly that one gene can cause such different things in so many different patients. And quite frankly, that's the heart of the mystery of genomics, right? We have this genetic code, and it can be different in just these little ways, and that adds up to all the ways that we're, diverse, and that's beautiful. But at the same time, it's kind of like, how do we start to learn those patterns? And sometimes, just like with a computer, you look at the edge cases, and so we're really losing something as a civilization by not applying these resources to these rare and unprofitable illnesses, because they have so much to teach us about how biology works. And so I would say it's one of the coolest things I've been involved with recently, the application of these type of deep learning technologies to medicine discovery and medicine repurposing for rare illness. And then at Research to the People at Stanford, the program with which I'm affiliated, we consider ourselves patient-led. We sort of initialize projects based on experience and needs of patients, and we sort of let the patients be, at the table when we're making decisions. So from a human-centered AI perspective, I just think this is such a good example. There's this powerful tool. And what we're trying to do is make sure all the stakeholders have a say in how it's applied. What do you think, Avi? Is that a good example?
Yeah, definitely. I was wondering whether new minds here would have some questions. Uh, okay, okay, okay. So let's. Shall we have a talk on any other topics? Like, you want to talk about something else?
Yeah. Let's see.
How many things we can, yeah.
No, it's true, and I'm actually in quite a chatty mood, so I'm very happy to
So,
talk about anything.
yeah. So one thing comes to mind, like, how did you react to ChatGPT scenario?
Oh, just broadly. Um,
Yeah.
well, um, I
Sorry.
mentioned, my early work in large scale GPU computing was for Google and in the field of language translation. So at the time I was working, there were no transformer architectures.
Yeah.
The best tools that we had to study language with AI were convolutional neural networks. Um, I don't know if you guys have ever seen, sometimes that you'll see a picture of like a really poorly translated street sign, or, something that's really poorly translated and it's kind of funny. Um, that's what language sounds like coming out of a convolutional neural network. And so obviously, and actually probably specifically, um, the issues with convolutional neural networks led at Google to the invention of attention and the transformer architecture. So when that first came out, when it was first released, it was a big deal in my life. And then obviously, the research that I do has very much moved in that direction. Um, and it's just so exciting actually seeing how these tools integrate in societies and projects. Um, the language technology I built at Google was actually really interesting because it was used to support a decentralized population of about 60,000 language translators. The system was, and it's something you can think of as like Uber for translation. So anywhere in the world, you have your phone, you get a piece of text, you translate it, you get paid. That was the type of system that we were operating. And um, something that was pretty fascinating though was how much releasing an AI into that system had very unintended consequences. We
Yeah.
found out that there were some translators who became, let's say, lazy. They came to rely on the AI too much, and the quality of their translation went down. We had other translators who used it very well, and we would see the quality of their translation went up. And we didn't expect anything like that. And so there really is a lot to learn right now as we're sort of adding this new element to existing systems. And, it's an element that is far more advanced than the AIs I was working with back then. Um, the question of like intersecting human intelligence with artificial intelligence, I think, is maybe one of the most important questions on the planet right now. How do you do that properly? And Avi, this is a really good moment for me to shout out the program I'm running at Stanford right now. This is something we're calling the Rare Disease Hackathon, but
Yeah.
it's
Yeah.
really more of kind of an extended research collaboration project.
Cool. But
Um,
I'm also thinking about why we should be thinking more about open source models of AI rather than the proprietary ones. I think that also has a very significant impact on the way the AI would respond, especially when it comes to the usage in medical systems.
I couldn't agree more. And I would say too, I'm obviously a strong advocate of open source, and I personally
Yeah.
believe the future of AI is open source. For reasons of hardware, software, and organization, the edge that closed and centralized models have over open models, I believe it will decrease and decrease and decrease until it's negligible. And there will also be advantages from the openness by seeing the way that um, the same models interact with different people's data. We'll be able to build a much stronger picture of how to train a model for a desired purpose. Past the general, though, there are some reasons why, very specifically, I think medical AI has to be open. Um,
Yeah.
the first one is at some point soon, there will be a medical fatality because an AI made a mistake. Bummer to say that, but the medical system's so huge that it is just a matter of time till that happens. When human doctors make a mistake, we have a process which is called a morbidity board, where a physician has to sit with a council of their peers and kind of explain their decision making. And this obviously contributes to understanding if a particular doctor made a good decision, if a particular doctor is a person who should be able to continue practicing medicine. But it also helps us learn about the modes of failure for the entire health system. So the output of these morbidity boards is a really important piece of how we establish medical best practices generally. And imagine you have a closed system that's proprietary, and you can never go see what data's in it or how they set the hyperparameters. So yeah, I very much think that not only are open AIs critical for medicine, but we're going to actually have standards developing over the next 2 or 3 years for what I like to call a medical grade AI.
Yeah. Uh, and what do you think about like the small language models? So are they really efficient in medical systems, like, or should we have to rely on LLMs only? Because the small language models can be run on very low end configurations. So can we use them as well on medical language?
I myself very excited about small language models. In particular, recently, Avi, I don't know if you've seen it, but the Orca models from Microsoft are quite incredible. And my rule of thumb when it comes to parameter scope or model size is you want as many parameters as you need, but you don't want more parameters than you need. The more parameters you have kind of past the level of performance that's desired, the more chance there is for hallucination, the more data you need to train the model, the more cost, the more compute to train the model. So actually for our hackathon right now, one of the teams, which is being headed by my friend Gaurav, who I believe is a gentleman from India, he's adapting the Orca models, which are these 7 billion models, to do something a little boring, to write medical documents. Obviously not the most glamorous thing, we're not discovering the cure for cancer, but we're taking a lot of work off a doctor's plate. I don't know a physician who doesn't complain about paperwork and insurance forms. And imagine for each doctor we're able to free up 2, 3, 4 hours a day sometimes, maybe, for them to be actually working with patients and practicing medicine. So yeah, I believe small language models have an enormous role to play. And I fully believe that the future looks like a very diverse ecosystem of models in different sizes.
Okay, so do you think like how can we integrate these systems in educational institutions? Any
It's a
first
very
step?
good question.
Yeah.
It's a very good question. It's also kind of a challenging question because
Yeah.
it's going to
I'm
change
just
very
asking like
quickly.
what can be the first step we can take? Like just any suggestions you might have.
Yeah. I believe that there are so many problems that need to be solved right now, and that have a lot of potential to be solved with large language models. I think that large language models are kind of unique because of the diversity of collaborators necessary. So for our hackathon, for example, we have machine learning scientists working closely with doctors, and then that's to solve a specific problem. So I believe that the way the educational institutions should approach this is project-based, and what they should really do is find areas of impact and problems in their local context, and then help students and practitioners come together, form little teams to explore the application to the problem, and then follow the DeSci principle of sharing early and often. Because yeah, this field progresses so fast, and there's so much to learn that even groups of students right now are making important contributions.
Thanks so much, Stanley. Thanks so much. That's wonderful feedback you gave. So, so we have around 5 minutes to go. So if anyone has a question, ask. Please. Yeah, come.
Hi, my name is Pranay. I just joined lately. So my two questions are there. Can you see has we seen in the movies in Transformer, like robots are uh, human robots are going all over the earth and they are making humans like a shit. So can we think like it could happen in future, and if so, then how close we are, like in 10 years or 20 years? I know it can be more than that. And the second question is, what I personally feel like, human bots, like male bots and she bots, what we say, these two types of bot can change the culture of our humans. So what do you think, like can they change the culture?
I think so. I think these things are going to change the culture. But I think we can't take for granted that things can change in a lot of different directions. And so, once again, I think conversations like this are so important because they're going to help us find the right path. When it comes to embodied AIs, I used to be quite skeptical, but a number of things that have happened in the past month that make me think it's going to happen, and it's going to happen pretty soon. And that would be, in particular, OpenAI has forged relationships with a number of robotics companies. At the same time, they've announced a number of results from their multimodal vision transformers. And I've seen a couple demos of what their visual transformers. And so these are systems that can, you give them an image, they give you text, you give them text, they can give you an image, they can sort of understand and translate back and forth. I've seen a couple demos that I'm going to say they spooked me. And from what I've seen, there's not too many more steps until you will have a embodied intelligence that's able to be told to do something and do it.
Okay, cool. Like, would you think, from your perspective? I want to know your perspective. Like, what should human think to sustain in future? Like, can you differentiate the work, what humanoids or human can do? Like,
I think he's hinting at the Turing test.
You know, it's an interesting question, and it is a little freaky because I would say every month I think that there's more that an AI is going to do. But I do think that we will have a role as the evaluators in many cases. I think in many cases we will see things that AIs produce, and then using our holistic knowledge of the world kind of give thumbs up and thumbs down. So I think we're unfortunately all destined to become managers of systems of AIs who help align their activities with different goals in the real world. And I actually sometimes like to imagine that if you think about the world as a body, we're going to be the nervous system. We're the connection between the artificial intelligence and the outside world. We will be how the artificial intelligence evaluates what it does, collects data, and interprets data.
also in space mining, how could humanoids can help? Like, I think it would humanoids can need less energy than what we are launching today for that purpose.
Avi, did you plant this guy? This guy's questions are too fun. And yeah, this is a funny thing. I'm actually the head of AI and I'm the head of AI and simulations for a project that's sending up a lunar rover on the 2026 Artemis mission. And I actually believe quite strongly that in order to become a Kara-Dashev 1 civilization, the Kara-Dashev scale is a scale that evaluates the progression of a civilization based on the total amount of energy that it can mobilize. So we're right now Kardashev 0, barely. And Kardashev 1 would be if we controlled all the energy of our sun. I believe in order to get to that point where we can build a Dyson sphere, we will actually have to mine a significant amount of helium-3 from the moon. And I believe AI will be critical for that. Lunar and space operations, very challenging. So yeah, I think we are going to need probably to build a lunar internet that will operate a fleet of robots to process helium-3 and send it back to the Earth.
Yeah, thank you.
Thanks, Brian. So I think
Sorry, guys, I don't mean to get too sci-fi for you.
yeah. he's been really very excited since yesterday. So and since we were talking about this ideathon, he's been very supportive from the beginning. So thanks, Pranay. Okay, so I think we can wrap it up now. Stanley, we'll let the conversation going. So this is only the beginning. So really looking forward to the next sessions with you. Yeah.
So excited to be here. Thanks again, you guys, for having me, and thanks for doing this. Like I said, I think this is one of the most important types of conversations we could be having. I feel so honored to be a part of it, man. So thank you, Avi.
Yeah, thanks. And if you have any questions that might come to your mind afterwards, after the session, you can send a message to me, and I can ask him, and he can I can send you the reply. Yeah.
Oh, sounds so good. And anyone looking to get involved in OpenSci or DeSci, in these areas, reach out to Avi, or follow me too. I'm on Twitter. I'm at Science Stanley.
Yeah. So the scientific side of things have really erupted since DeSci came on the X platform, which is like X Twitter. So yeah. So let's call it session end. So